For today's lesson, we're going to talk about the geometric mean, the difference between the geometric mean and the arithmetic mean, and the way that the geometric mean applies to right triangles. So for the basics to start, for the basic understanding of numbers, the geometric mean is different than the arithmetic mean in a couple of ways. The main thing is that the arithmetic mean is the average of two numbers. Add any two numbers and divide by 2, which will get the arithmetic mean. So for our example here, the arithmetic mean of 4 and 9 is 4 plus 9. Once you do the sum, then you divide by 2. So the arithmetic mean would be 6.5. Right? The difference now, the geometric mean, instead of doing the average of the two numbers, you take the square root of the product of two numbers. So now you would simply multiply the two numbers and then take the square root. So for those same example that we did before with 4 and 9, the geometric mean of 4 and 9 is the square root of 4 times 9. Remember, the asterisk is multiplication. So in that case, it's the square root of 36, so the geometric mean is 6. So there's a subtle difference there, but it is a different solution. So the arithmetic mean is a different concept than the geometric mean. So now, in right triangles, we have an application here, an example which I can show you. So when applying this to right triangles, you need this altitude. So the altitude is the segment CD, which comes from the right angle, goes down to the hypotenuse, creates a right angle, hence the altitude, and divides the hypotenuse into two separate segments, AD and DB. All right, so when you draw that altitude from the right angle to the hypotenuse, there really are two smaller triangles created that are similar to the larger triangle. This triangle ACD is similar to the large triangle ACB, and also this small triangle CDB is similar to the large triangle ACB. So that's really where this geometric mean comes from and how it's useful. We can find lots of different information from the right triangle just by using the geometric mean. So we're going to go through how the geometric mean in a right triangle is defined. So the first definition, the definition of the geometric mean states that the altitude of the right triangle is the geometric mean of the segments of the hypotenuse that it creates when the altitude intersects the hypotenuse. All right, so that's a lot of jargon, but here's the details behind it. Therefore, CD is the geometric mean of AD and DB. So going back up to our drawing here, CD, this altitude right here, is the geometric mean of the two pieces, AD and DB. So if we had numbers for these two separate segments, we could multiply them together and take the square root. That would result in the length of the geometric mean, which is CD. So that's described right here. So if you do CD squared, that's equal to AD times DB. That's another way to solve this as well. Right, that basically works on the square root of the product of those two segments. And of course, depending on which segment you're given and which measurements you're given, you can simply put those measurements into the equation and then solve those. Furthermore, down below here, the legs of the large right triangle are each separately the geometric mean of the product of the length of the segment of the hypotenuse adjacent to the leg and the length of the entire hypotenuse. This does work for both legs of the triangle. All right, so that seems to be pretty confusing, so I'll explain it to you this way. So using the legs of the triangle, there are two scenarios. So using that previous definition, we're back to the same triangle. So scenario one is that on the right side of the triangle, CB, which is this leg of the large right triangle, that is your geometric mean of the segment of the hypotenuse next to the leg, so DB, and the entire hypotenuse of the large triangle, AB. All right, so CB is the geometric mean of DB and AB. So we can use that same formula from before, CB squared equals DB times AB. And that's a simpler way of taking the square root of the product of two numbers. And depending on which measurements are given, plug those numbers into the equation and then solve. For scenario 2, we can use the same idea that we did with CB with this leg of the triangle, and now apply it to the other side of the triangle for CA or AC. So this leg, we're just going to use a reference from the other side, is the geometric mean of the segment of the hypotenuse next to that leg or adjacent, which is AD, times the whole hypotenuse length, which is AB. So AC is the geometric mean of AD and AB. Right? So using that idea, same equation as before, AC squared equals AD times AB. So again, the square root of the product of two numbers will help you find that geometric mean. And depending on which measurements are given, put the numbers into the equation and solve. So typical problems may give you the leg of the right triangle and the whole hypotenuse, and then you'll have to find the segment adjacent to that. Or one of the other versions, the whole hypotenuse, the segment adjacent, then find the leg. So depending on which situation will help you solve the leg of the triangle or the hypotenuse or the segment, but it really depends on which information is given. All right, I hope this clarifies the explanation of geometric mean, and there'll be another link posted for more articles for more information on this. Thanks.